adsorption is an interface transport process where chemicals moves from either the aqueous or gaseous phase toward the solid phase. Depending on the part of the solid where the chemical is retained, sorption can be categorized into adsorption and absorption. If the chemical is retained just on the surface of the solid, this process is called adsorption. The chemical adsorbed by the solid is called the adsorbate, whereas the solid adsorbing the chemical is called adsorbent. If the chemical penetrates through the surface of the solid, the process is called absorption. An example of chemical absorption is the purification of natural gas by passing the natural gas through an aqueous solution of an ethanolamine in which any acid gases, such as hydrogen sulfide and carbon dioxide, are removed from the natural gas by reacting with the ethanolamine. In this video, we will discuss the processing of data from an isotherm adsorption experiment, which will be fitted by an isotherm adsorption model called Freundlich model to determine the values of adsorption parameters. In thermodynamics, an isotherm is a line on a graph that represents changes in volume or pressure under constant temperature conditions. In the Freundlich model, Cs is the adsorption of the adsorbate by the adsorbent. It is commonly defined as the mass of the adsorbate by unit mass of the adsorbent, using a typical unit of milligram per liter. On the other side, Cw is the equilibrium concentration of the free adsorbate in the aqueous solution. Adsorption equilibrium is usually reached after hours of thorough contact between the adsorbate and adsorbent. Kf and N are parameters characteristic for the adsorption capacity and adsorption intensity, respectively. A larger Kf value indicates a relatively higher capacity for the adsorption of the adsorbate by the adsorbent. And a smaller N value indicates a relatively higher intensity for the adsorption, meaning a faster adsorption process. These parameters can be determined by fitting the experimental data with the Freundlich model. Problem background. In an experiment using biochar as the adsorbent to remove heavy metals from aqueous solutions, we aim to compare biochar's effectiveness in adsorbing different metals. Basically, due to adsorption of the metal onto biochar, there will less metal in the aqueous solution. As a result, the aqueous environment is decontaminated. Therefore, to design an isotherm adsorption experiment, it is important to record the initial metal concentration in the solution before adsorption, and the equilibrium metal concentration in the solution after the adsorption, as well as the mass of the adsorbent and the volume of the solution. In an isotherm adsorption experiment, a series of solutions need to be prepared, typically coming with the same volumes but different concentrations covering a broad range. The same amount of adsorbent is added to each of these solutions. The mixture will be allowed for thorough contact through continuous shaking for several hours or longer under the same temperature conditions, so as to ensure that equilibrium can be reached. Problem statement. Let's say that we have completed the isotherm adsorption experiment to compare biochar's effectiveness in adsorbing different metals from aqueous solutions, and we have obtained the raw data as shown in the page. The volume of the solution is consistently 500 milliliters, and the same mass of biochar of 200 milligrams is used for the adsorption. However, the initial concentrations of copper in these solutions are different, resulting in their different equilibrium concentrations. If we recall the Freundlich model, we know that the equilibrium concentration Cw has been measured and recorded. But we are missing the adsorption Cs, which is the mass of adsorbed copper by unit mass of biochar in this problem. We can use the highlighted equation to calculate the adsorption of copper by biochar, and then add this column to the table. Now we have both Cw and Cs for each of the 5 trials. As we plot these raw data of Cw and Cs, we can see a typical curve of Freundlich model. The question is, how do we use these data to fit the model and determine the values of parameters Kf and N? In this video, we will use the linear regression technique to solve this problem. In order to use the linear regression technique, we must linearize the equation of the Freundlich model. If we turn this model into log scale, such as using the natural logarithm, we will obtain a linear relationship between the natural log of Cs and the natural log of Cw. Hence, instead of plotting Cs and Cw, we will log these raw data on their natural log values. In this linear equation, the slope is the inverse of n, and the intercept is the natural log of Kf. As we use the least square linear regression technique to find the linear equation best fitted with the experimental data, we find that the slope is 0.5916, and the intercept is 0.8126. Finally, the values of N and Kf are 1.69 and 2.25, respectively. If we have the data for the adsorption of another metal by biochar, such as cadmium, we will be able to find the values of N and Kf using the same method described here. These parameters can then be compared to understand the effectiveness of biochar for adsorbing different metals or other contaminant, especially in terms of the adsorption capacity indicated by Kf and the adsorption intensity indicated by N. Thanks for watching. Leave a comment if you have any further questions.